Most welcome to the platform of Inside Chemistry, guys. So we are having today's lecture on the topic of most important concepts of the organic mechanisms that involves the heterolytic cleavage and the homolytic cleavage and reaction intermediates that are formed by heterolytic cleavage. First of all, let me talk about what are the reaction mechanism as we have talked about in our previous videos, but let me to describe what is the reaction mechanism. Let me come to us. Yeah. The reaction mechanism is a detailed description of how bonds are broken or formed as starting material is converted into product. And this is all about the reaction mechanism that explains how bonds are break and how the products are formed. And this also explains the steps. The one-step reaction is called as concerted reaction. Now come towards the stepwise reactions that if a stepwise reactions involve more than one step, then there must be a reactive intermediate formed between the reactant and product. This is the most important concept of reaction mechanism, that a reactive intermediate is formed between the reactant and product. A starting material is first converted into unstable intermediate which is called reactive intermediate, which then goes to form the product. Here A is reactant, and then it is converted into reactive intermediate, and then reactive intermediate is converted into product. Then let's come towards the main topic. Our main topic is the homolysis or homolytic cleavage. What is homolysis and homolytic cleavage? When bond is break, then the equal distribution of electrons is said to be the homolysis or homolytic cleavage. When electrons are distributed equally, when the bonds are broken, then it is called homolytic cleavage. This is all about the homolytic cleavage. I hope you'll understand that when the bond is break, for example A and B is break, then the electrons are distributed equally. A has equal electron and B has also equal electron. That is called homolysis or homolytic cleavage. This is the most important concept of reaction intermediates and reaction mechanism, that when A and B bond is broken, then A and B will distribute equal electrons. Now come towards the representation of the electron distribution. This distribution is represented by half-headed curved arrow. This is the most important concept, that half-headed curved arrow is used to represent homolysis or homolytic cleavage. That equal distribution of electron is represented by half-headed curved arrow. This is the most important point of the homolytic cleavage and the reaction mechanism, that whenever you will saw the half-headed curved arrow, this is used to represent the homolytic cleavage. You must understand that this is the representation of homolysis or homolytic cleavage. Now, what is the heterolytic cleavage? Heterolytic cleavage is unequal distribution of electron. It is simply defined that electrons are unequally distributed between one atom and another atom when the bonds or between two atoms or molecules is broken. then first species or second species will be more electronegative than another species. This is the heterolytic bond breaking, that one substance will get more charge and other will get lesser charge. You can also uh, state that one substance is a major substance and another is a minor substance. That is called the heterolytic bond breaking. And that's also all about the electronegativities, that one species is more electronegative and another is lesser electronegative than another molecule or another atom. So let's come towards the heterolytic bond cleavage and another concept, that how we can represent the heterolytic bond breaking. We can represent the heterolytic bond breaking by full-headed curved arrow. This is the most important point, that we can represent the heterolytic bond cleavage by full-headed curved arrow. This shows that the complete transfer of electron pair. You know that two electrons are transferred from the bond, from when the bonds is break uh, between two atoms, then the breaking electrons are moved towards one atom, and it is shown by full-headed curved arrow. Here you can see that in AB, when bond is break, then the electrons are moving towards B, and hence B is said to be more electronegative than A. Here also we have the concept of carbocation and carbanion. These both are the unstable reaction intermediates, but the main difference is the carbocation is positively charged carbon and carbanion is negatively charged carbon. That are the important reactive intermediates. And let's come towards more about the reactive intermediates from heterolytic bond breaking. The reactive intermediate formed by the homolysis or homolytic cleavage is the radical. In the first step, you can see that the representation of half curved arrow, half curve headed arrow shows that there is homolysis or homolytic cleavage, which forms a radical when equal distribution of electrons is happened here. And at heterolysis, we have two types of reaction intermediates. The first one is carbocation and another one is carbanion. Now see how these are formed. At this step, you can see that the full-headed arrow shows that the electrons are transferred, or electron pair is transferred to the atom that is adjacent or adjacently adjusted to the alpha carbon. Then it forms carbocation as reaction intermediate, or it is also called as the major product of heterolysis. At the last step, here let's see the representation of full-headed curve arrow that shows that the electrons are moved towards the carbon, not to the adjacently adjusted to the atom. Then it forms carbanion. When the electron pairs are transferred or moved towards alpha carbon, then it forms carbanion. Okay, this is the concept that we have three major reaction intermediates: radical, carbocation and carbanion. And this is another most important concept of the reactive intermediates, that radicals and carbocations are the electrophiles. This is the most important point, that radicals and carbocations are the electrophiles. You know that electrophiles are the electron loving species because they have electron deficient carbon and they want to carry and they love to carry an electron. And another one, the last one is carbonine, and this is the nucleus lover, and this have um, electrons, and this is electron rich species. And this is all about these three reactive intermediates. The radical and carbocations do not have electrons, and the last one is electron sufficient. Now this is the concept that how bonds are formed. At the first point, it is said that if two radicals are there, then each will donate one electron and they form two electron bond. And if two unlike charges are there, then the negative charge will donate its electron pair, then the bond is formed. This is all about the arrows. The full headed arrow, straight arrow, shows this is the name as the reaction arrow. You know that this is called the reaction arrow. The full headed arrow is the reaction arrow. It is used to draw the starting material and the products in the equation. This is all about the full headed arrow. And the second one, the double reaction arrows. This is drawn between the starting materials and the products in equilibrium equation, and double-headed arrow drawn between resonance structure and the full-headed curve arrow, which we had discussed here, that shows moment of an electron pair, and a half-headed curve arrow. This is also called fishhook, which shows the moment of single electron, which is all about the arrows. And hence this is the concept of the whole organic mechanism.